The topic of this part of our little conference is AI in production, and also the advantages of understanding the multimedia asset that you own. So I will be talking about the family of services that we've built for Hubert, based on deep learning techniques that are able to analyze the visual assets on entry to the system and provide us with a lot of very valuable informations just automatically. Which saves a lot of work and also opens new possibilities to the whole system. So what are we trying to solve with this? Because this deep learning didn't appear in the system well just because it's fancy and it's new and there's a lot of hype around it. We had some real problems to solve. And this AI looked as a very promising solution to us. So first of all, the AI can provide us with the automatic classification of the photos. So it can add a lot of information to the metadata that is usually delivered with the photos. This metadata delivered by the different providers is very difficult to integrate because it's unreliable. Very often it is scarce, or there's no metadata at all, and it also is inconsistent. The information are placed in different tags. There's no good standard for IPTC. Well, standard is, but a lot of entities does not adhere to it. So these automatic classifications allow us to do it ourselves without involving a lot of the additional manpower to do this. Of course, the additional keywords or additional information about the contents of the photo allows us also to improve our search engine, which in turn allows the editors to easily find the photo with some particular features on it. The information about the contents of the photo are also crucial for these selection algorithms I was talking about in my first presentation. So the whole logic that for selection that the customer can set is very heavily grounded in this AI analysis we are doing here. And the next step is, of course, also very important, which is the actual production. This is this smart cropping algorithm that I was mentioning, which in turn needs to have a lot of information about what is on the photo and where it is on the photo. Solving this problem allows us to solve this final problem, this core problem, which is the scaling of the whole solution and limiting the manpower cost needed to satisfy the customers. So I would like to introduce to you Hubert AI YOLA services, called YOLA in short, which are able to provide us with all this additional metadata. So let's start with this classification and tagging. You can see here, this will be the screenshot from the kind of demonstration portal for the services, showing what the AI can see about the photo. So it's all generated automatically. The photo has been just dropped in, and this information that you will be seeing are returned. So first of all, you can see that these on the right side we have some classifications about the photo. On the left side, it detected the track racing, so it's able to detect the logical information about the photo, and also detected the motorcycle racing. On the right side, we have something which is called confidence score. So the higher it is, the more AI is sure about it. The other network also detected the crash helmet here with high confidence. And we also have an identified motorcycle with the position information, and the person. This red box is a detection of the person. So on the second screen, you can see how how reliably the AI can, for example, classify the sports. Here, with just an image, it was able to find out that this is the volleyball, that the photo is the main theme of the photo is a sport. So there's information about the composition. And the second network also returned the information that this is for sure the volleyball. The sports ball has been identified, and as well the person here has been identified with the red square. Another example, the topics of this will be animals. There is a pair of people detected, and the horse is detected as well, plus some additional elements on the photo. And the area of the horse is detected as well. What's funny, they also detected the other horse which is standing behind the one here. And then the next example shows us for example, the classification of the nature. So the topic of the photo is nature. It contains mountains, landscapes. There is some valley here. So a lot of information we are getting as a tags from the scratch, from the automatic analysis. Another example, we have the information that this is the old photo. There's a pair of people here. They have a camera. There's a tripod, and so on. So well, still having the good information. But this is the general information about what's on the photo. But during our selection process for customers, the customers very often ask us to, for example, keep our photo selection stream safe. So the Yola services also provide us with a number of tasks, allowing us to fine-tune the safety of the stream to the particular customer wishes. First and foremost, of course, we have the tags connected with the nudity and erotic themes. This photo is well, quite safe for European standards, but still the neural networks start to indicate that there is some nudity, but this is classified as a called safe nudity, so no crucial parts are exposed. Plus, of course, we have some additional tags to this. This is kind of escalation of this topic. So this one is I would say less safe than the previous one, and it also includes the safe nudity. If you can see this, this confidence level has raised, and it also indicated the erotic situation here, possible erotic situation. I think we should start selling this to introverts as a service. Will go up, and this is the well, I cropped this one, and this one also this one got the straight safety warning that this contains nudity and there is the breast exposed. This is probably the erotic photo shoot, so this this wouldn't be exported, and if customer doesn't want to have unsafe content. And this was also cropped. This is the erotic photo, and so it got two warnings. It's an erotic and nudity, so it would also be cut off from all streams that are supposed to be safe. But nudity and erotic are not the only topics that limit this the safety of the photo stream. We also detect drugs, for example. In this image, you can see that the photo has been tagged as toxic because guy is handling marijuana here, and even the marijuana has been detected, which I was personally surprised. And I have to ask me how did he train it so good? Also cigarettes. The smoking cigarettes, we had some requests from the customers that we shouldn't show people smoking cigarettes because it was well, not safe for them. So we also made a detection of the smoker and smoking persons on a photo. The same goes with the alcohol and drinking. There's a number of tags that warn us against the alcohol use on a photo. And of course, there is a violence detection. So the violence detection can detect any situation that is probably violent, like people with guns shooting at each other, the explosions, smoke. It also contains the detection of so-called drastic theme, when there are people who are covered with blood or wounded in a serious way, like this in this image. All these additional safety tags allows us, as I mentioned, to make our stream adjusted to the level of safety the customer demands from us. The other factor that can influence the automatic selection process is the quality assessment. We have in our database, and the customer have in their databases, a lot of photos of different quality. There are the old photos, the photos with a visible noise or visible JPEG artifacts, low resolution stuff. Well, a lot of things that generally differs in the quality level. The easy algorithm to find out which photo is good and which photo is bad is just to find out what is the resolution of it, but it's not reliable because somebody could just pump up the resolution of the photo. So we also employed the deep learning based technique in which the neural network has been learned how to distinguish the bad photos from the good ones. This neural network just produces the quality score for each of the photo. Generally, the photos with the score lower than 5 are probably the photos of the bad quality. So we are relying on this technical factor to in the process of choosing the photo. If we have the lot of photos of the same person, for example, we are tending to pick the one with the best quality to raise the quality of the whole stream. The other factor here is called aesthetic quality, and well, as far as aesthetic goes, well, people differ in judging this. This photo has also been tagged with some tags denoting that it probably has a bad quality, and this is the bad quality photo of the very high quality actor. Okay, let's go to the next element that we support is a composition analysis, and there's a lot to swallow on this screen, because there's, as you can see, the bunch of rectangles and polygons drawn here. This is what our neural networks are returning us about this photo. So the analyzes go in separate directions. First of all, the one is this the key photo area. There is a network that is able to find out which elements of the photo are the main elements of the photo. So it somehow detects the focus, detects the layout of the photo, and is able to find out the outline of the area which has the most impact on a visual side of the image. The key photo area is here rounded by this green line, and you can see that it includes this stop sign, which is a part of the composition. It includes this lady, part of the guy here, but generally it generally tells us that the photo has been focused on the sign and on the lady. And these three guys in the background are just a background motif of it. The second one is a person area, which is denoted here with the brownish outline. So the other network finds out the person outlines on the photo and returns it to us. So we can see that there is one outline for a lady, and each of these guys have their own outline as well. And there's one guy here who is not visible, as there's only his shoulder here, so it's also denoted with this line. The information about how many pixels does the person use in the image is also used by us to determine which person is the most prominent on the photo. The third element which is detected are of course the face detection. Is the face detection. So the deep learning is detecting the faces on the photo. It is denoted with this blue rectangles. As you can see, it also detects the photo when the person is it's not in focus. It's very blurred. It has a bad quality. It's quite powerful to it is quite powerful to detect even very small images of the faces here. You can also see that the lady and the rest of the guys have small red dots in the corner of the lips, on the nose, and on the eye pupils. These are the key points, features of the face, which are also detected by this network, and this allows us to find out what is the position of the head, which then can, as you will see, will be quite important. Along with the face detection, we also built the head area estimation, which is denoted by this violet rectangle. So it shows us the position of the whole head, because while making automatic crop, we wouldn't like to cut out the person at the top of his face. So we are just extending this area depending on the position of the head to be able to do a better crops. There is also text detection and OCR here in place. You can see that there's this pink outlines are detecting the area with the text in it, which, as you will see, will be also used later on during this automatic crop process. And at the end of it, there is object detection. So these are these greenish boxes. You can see that it detected the stop sign and detected the backpack of this guy and tie of this guy. So it detects the over 90 elements of 90 classes of objects, which can serve then as additional information for the crop or for the search. Okay, so let's see how the face detection and how the and the focus area detection can help us during the automatic crop. Yeah, we have the image like this, which is not the image with the central composition, but the main objects are on the right of it. We detected the faces, we detected the heads, and also with the green line system detected the key areas here quite nicely. And then if we would use just a naive approach to the cropping, so just take the crop from the center, we would land up with a crop like this, which is, well, kind of acceptable, but it's not nice. I wouldn't use it as a artwork to promote the movie in my service. But because system right now knows that these key persons are on the right side and it knows the position of their faces, system can then fine-tune this crop and do it like this. Yeah, so this will be the resulting crop while applying the additional information about the photo content, which is quite much nicer. The information about the focus focus we are detecting here with this green outline is also crucial in case there are no living persons on the photo. So especially, for example, when we have the photo which from the animation like this. So in a photo with the animation, we wouldn't have any clue how to crop it, and this focus detection allows us to focus on the area it detected. So in this case, this wally will not be cut in half, and also this little guy here will be cropped properly. And by the way, we can see that we are also detecting robots here. Okay, so as I mentioned, the Viola also detects the text and performs the recognition of the text, reads the text to the text, and this is something that we use in two areas. It is very helpful while analyzing the posters. And also analyzing these title cards. So it allows us to find out that the photo here is a poster, and even analyze that this is the DVD cover. Like in this moment, you can see that DVD cover has a has a 74 of confidence, and the general cover is 081. So it automatically classifies this photo as a DVD cover. And it also gives us the geometric information about about the areas of the photo or the posters which are taken by the text, which is a great help in the case somebody would have to make a crop out of it, giving the automatic process the information that this block of the photo is a text. Please do not cut it in half, because then it's imminently visible. This information about and recognition of the text also gives us information about what language the text on a photo is in. So it can be automatically classified, like in this case, the poster written in German language, and the system will automatically distinguish this from the, for example, poster in English or poster in French, which will also have an impact on during the selection process, because if the customer is from France, we will not select him the German poster to send. Okay, so this is quite a new advance in our technology, because recently we started also the face recognition in our real services. We've worked on this quite a long time, and now I can show you the results. The information about who is on the photo, not that this is a person, but who this particular person is very crucial in during the selection process and also during the cropping process. We have two ways of finding out the persons on the photo. We do it two ways to limit the uncertainty of the recognition. So the the one approach, which is very handy in a situation where we do not yet trained our neural network to recognize the particular person, is to use the language processing techniques to extract the names of the actors from the IPTC tags. So the service reads all the tags and then uses deep learning to find out where are the names of the persons in it. So, for example, given this caption abstract, it is able to produce us the list of the persons like this. But it also this is not a pattern matching. It doesn't just try to find out the patterns, because as I mentioned before, the tags sent by the providers are a mess, so they do not adhere to any standard. It is able to identify the names. It is also able to identify the additional information about the placement of the person on photo. So this R's, L's, and so on. You can see it here. It supports 90 languages, so we are able to read this persons from the photos sent us by from all around the world. And what's most important in this case, it is able to automatically distinguish the real people names from the fictional roles names, because it is very common in this captions that the names of the persons in the movie are mixed up with the name of a real actor. So there's a whole bunch of logic that automatically distinguishes, tries to find out which one is the actor and which one is a role. And this one is expressed here in the form of this score here. Yeah, so the higher the score, the more sure we are that this is the person, not the role. And during the process, we are also making the cross-check with our database person of MediaPress. So we are also able to deliver the additional metadata like the gender, like some external IDs like IMDb ID of the actor, and even some information about its achievement, like here this is the actor, soundtrack, director, and so on. But the real fun begins when we start to identify people on the photos without any clue from the side of the legend or caption. So these are the results of our own face recognition neural network that is now able to. It has been trained on over 10,000 of people from the world of media. So these are the actors, directors, moderators, and also some celebrities. It also includes this. Of course, it also provides us with the confidence measure here. Well, Heath Ledger is not 100% here because he's wearing the wig, but despite wearing the wig, he's still recognized very well. We are this service also provides us with information about the exact position of the head. You can see that this PGO and role here define to us how the head is positioned in the space of the photo. And it also provides us with the tags about the quality of the face. I mean, is the face in focus or the face is not in focus? And as far as the emotions expressed by the face is concerned. So we can see, for example, that Courtney Hope has a good quality, and the positive tag means that, well, the view of the person is generally positive. And it also she got the tag that she's slightly smiling, as you can see. The head ledger here is well, the quality is good, but guys has just doesn't express a lot, so it's kind of neutral. There was also the photo of the guy who is difficult to identify because of the position of this head. It's not front, it's not even profile. It's we are looking at him behind the ear, as we can see here. And there's also the situations where there is a partial occlusion of one person with another, or with a microphone, or with other item. So the system also indicates to us that this confidence can be additionally lowered by some, well, interference with the image of the face. In this case, this is the tag called many faces, which includes that there is one face over the other one, so there's partial occlusion, and this may be not the exact match, but nevertheless, it's still recognized Casey Affleck with a reasonable confidence. And there is this Greta's, I won't pronounce it, which is plainly smiling. The information about the faces, about who is on whose face it is very important while we are preparing the crop in a composition like this. Yeah, this is quite difficult composition if the customer wants to have this image cropped to the square or to the vertical format, because we will have to choose somebody on the photo and cut out the rest of the crew, and of course it won't be a good crop if we should cut out the main person in the movie and leave on the photos some third row actor or somebody, or somebody who's just there by accident. That's why if we have the information that, for example, let's say this actress is a top actress in this content, we are able to focus our cropping algorithm to leave her on the photo and cut out the rest. We can do it because, as I mentioned in the first presentation, these photos during production are in the context of the content. So we have the metadata about the movie, we have the whole cast, and we can use it as an additional clue for the smart crop mechanisms to indicate that, okay, these persons are important in this cropping process. And there is, of course, from the one side, there is now overabundance of the visual material available. Usually, there's a lot of photos available, a lot of materials which can be used. But there are some cases, especially with older movies or with some black and white movies, that these photos are very scarce. And they usually have the the low quality, the low resolution. And as you all know, right now the 4K is the king and 8K is lurking around the corner. So there's need for high resolution photos here. There is a family of algorithm and techniques and in deep learning which allows to prepare something called super resolution of the photo. So it's not the upscaling in a classical form. It is done by the neural network, quite sophisticated neural networks, and it is meant to preserve as much details as it gets, but to scale up the photo with a factor of 2 or a factor of 4 even. So once we have the photo with the lower resolution, like this one on the left, we can pass it through the neural network and get the super resolution version of it, which is, as we seen, quite acceptable once sent to the customer. It gives much better results visually. And it's very in some cases this is the last result to which we can use to provide the customer with a photo. Okay. So we are not stopping here, of course. There are some exciting new projects running right now, which will add additional functionalities to the whole system and allow us to provide the more exciting content. So this is the list of what we are working on right now. First of all, we would like to do the automatic cutouts. So we would like to be able to, especially during this title card, this thumbnail generation, it's often used as a way to remove the background of the person and, for example, make a place for text. So this will be employed. The AI will help us to automatically prepare the cutout of the person on the photo. Sometimes, due to the compositional stuff, it would be also nice to be able to remove object or remove some small text from the photo to make place for a title. So we are also working on algorithms to automatically remove some portions of the photo in an intelligent way. So the photo, for example, text will be removed, but it will not leave the hole on the photo. It will be filled in automatically with a proper pattern, taking account the whole composition of the image. There was also some proof of concepts regarding the automatical title card or thumbnail generation for replay programs. This is what I was mentioning at the beginning of my first presentation, that the more and more services are using this replay approach, which is just taking part of the live program and generating the video on-demand asset. And this video on-demand asset would be nice that it should have the proper title card automatically, because there's a lot of this program, a lot of these images. So not to choose randomly one of the frames of the video stream, but choose it using the AI. Choose the photo with which has a proper composition and which has the place for placing the text on it. So everything could be done automatically, having this deep learning techniques. We're also considering applying this to the automatic start-stop detection, which is also connected with these replay programs. So it's this is the automatic way to define the boundaries of the programs, because as we know, the broadcasters are not very exact when they are giving you the start time and the end time of the program. There will be also the automatic keyword/tag generation from text. So we are also looking at the textual metadata side of this equation, and we'll be able to generate the keywords and tags for searching or for similarity purposes automatically out of the texts and and possibly also the text from a different languages. Because as I mentioned, the database we have in Hubert and in TVMan is multi-language in nature. So sometimes we have a lot of text in one language and less text in another language. So using this multi-language approach, we'll be able to do it better. There's also a whole topic of building the next generation of the recommendation system. Based on the AI analysis of the text. These there was from the last 1.5 years, there is a very big advancement in the techniques of analyzing the text, of knowing about the text. You know, the networks start to understand what's written in. So it can be nicely used to put to work in a recommendation system that will be able to read the semantics of the text. So this should give us the very nice results as far as the similarity is concerned.